What is up, YouTube? Welcome back to this video series of solving Leetcode SQL 50, a great set of questions for SQL to cement your understanding of fundamentals of SQL. We'll be continuing this series with 5 more questions today, and these questions will again be based on joins. We have been doing questions on joins earlier as well. These will be a continuation to that, and I think there is one question on a basic aggregation function that we'll tackle. So without any further ado, let's get right into it. First question, it's called employee bonus. Here are the tables: employee table having columns employee ID, name, supervisor, salary. Emp ID is the column with unique values for this table. Each row of this table indicates the name and the ID of an employee in addition to their salary and the ID to their manager. So the ID of their manager. Alright, so we'll have various employees in this table, and I think the supervisor column will have the employee ID of a manager. Cool. Then the next table that we have is something called bonus, which has employee ID. I think that's the common part, and a bonus. Emp ID is the column of unique values for this table. Emp ID is the foreign key reference column to emp ID from the employee table. Said each row of this table contains the ID of an employee and their respective bonus. So whatever amount of bonus this employee is getting is stored in this table. Straightforward enough. Right, we have these two tables. Here is our problem statement. Write a solution to report the name and bonus amount of each employee who satisfies either of the conditions. Okay, the employee has a bonus less than 1000. The employee did not get any bonus. Return the table in any order, and we can have a look at the example. So first of all, from this problem statement, there are two things that I can deduce. One is that since we want to report the name and bonus of each of the employees, we're somewhere looking at a left join with the employees on the left, so that all of the employees are considered. That is something that I can deduce with the phrasing of this question. And who satisfy either of the condition, where either is used, we'll be using the or clause of SQL, and these conditions are on the columns bonus only. Yep, the value is either less than 1000 or it is simply not present. So we, while applying this condition, we only want to apply it on the bonus table, so it won't be a joining condition. It would be somewhere lying in the where clause for the bonus table, and hence we'll get a solution. All right, so this is helpful enough. Let me look at the example just to quickly see. These are our 4 employees. We have their names, ID, supervisor, salary. Supervisor, I don't think supervisor and salary are used in this problem statement, but yes, the bonus table has employee ID and bonus. We got the output names as Brad with a null because Brad had an employee ID of 3 and there is no bonus for employee ID 3, hence Brad got populated with a null. Then John had an employee ID of 1, again it is absent in the bonus table, bonus got populated with a null. And finally we have Dan. Dan has an employee ID of 2. His bonus was 500, which is less than 1000. Hence it got populated. But Thomas did not get populated, although it is present in the bonus table, because Thomas had a bonus of 2000, which is greater than our threshold. Right, I think it's simple enough. Let's write the code to it. Selecting the columns. Right, so name organically is coming from employee. Let me first complete the source table and the joins from the first table, that is employee. Give it an alias e, doing a left join. As we discussed, we want all the employees in this solution. Left join on bonus, call it b. I can now write it as e dot name as name, and b dot bonus as bonus. Yes, these are the columns. And yes, now we need to put the conditions on the bonus table, so we'll use where b dot, right, I'll pick it from here only, b dot bonus is less than, was it a strictly less than 1000, so less than 1000. And the next thing is an or, because either can be satisfied, or bonus simply does not exist. That means b dot bonus is null. B dot bonus is null. All right, this looks good. I forgot the basic thing. What is my joining condition? I'll be joining the common part between these both tables is the employee ID. That's what we'll be joining it on. So let me put it here. E dot employee ID equals b dot employee ID. That's how we'll be joining tables. Right. We have a select statements, our tables, joining condition, and the where clause. Let me give it a shot. Test case is successful. Let's submit it and move to the next one. Right, cool, easy enough. Moving to the next one. Students and examinations. We have the first table called students, student ID, student name. Student ID is the primary key column with unique values for this table. Each row of this table contains the ID and the name of one student in the school. So kind of a universe of all the students present in the school. Next is a table called subjects, but it only has a single column called subject name. Subject name is the primary key column with unique values for this table. Each row of this table contains the name of one subject in the school. So this is kind of a repository of the various subjects in the school, whereas this was a repository of the students. What I can see which does not sit right with me is we don't have a common column between these two. So these two can't be directly joined. Alright, let's move to the next one. We have a third table in this question called examinations, which has both student ID, which is common with student, and subject name, which is common with subjects. Let's go into it. There is no primary key column with unique values for this table. It may contain duplicates. Alright, so there is a possibility there is a student ID and a subject name that is getting duplicated. That means one student has taken multiple examinations for the same subject. That is a possibility. Each student from the students table takes every course from the subjects table. Right, this puts us in a pickle. We somehow want to combine the students table and the subjects table, but the problem at hand is the students and the subjects table don't have anything in common. Right. In such a case where we don't have anything in common, but we kind of want to make a complete repository out of it, we have to proceed with a cross join. This is the question where cross join will be used. Alright, because this information is given to us. Each student from the school table takes every course from the subject table. You kind of have to make a student subject combined cross join table and then move ahead. Each row of this table, this examination table, indicates that a student with ID, student ID, attended the exam of subject name. Alright, I think that is understandable. This table gives us the information about what exams a student took. So let's find out what they want us as a solution. Write a solution to find number of times each student attended each exam. So it is on the level of a student as well as an exam. And we have to find the number of time, that is the counts of these various examinations. Alright, that makes sense. Return the result ordered by student ID and subject name. Interesting. And finally, the result format is in the following example. Let's look at the example. I think that will be the best. We have the student table with these 4 students, these IDs, these names. We have the subjects table, math, physics, programming. So with the cross join, what we'll want to essentially achieve is with Alice and student ID 1, we should have 3 entries of math, physics and programming, and similarly for the rest of the 3 students, so that a master student subject table is used, and using that we kind of find information of the counts of examinations happening. So let's look at few examples. Yes, that's what we are having. For Alice, as you can see, for the student ID 111, Alice, we had all the 3 subjects. This can be achieved by a cross product or a cross join, a Cartesian product or a cross join. Hence, a cross join will be used in this question. And then we have a column called attended exams. Let's see how this is forming. We have an explanation over here. Let's have a look. The result table should contain all students in all subjects. Alice attended the math exam 3 times. Let's have a look. Alice had a student ID of 1, and 1 attended math over here, and over here. Yep, makes sense. That's why 3 got populated. Bob attended math exam 1 time, the programming exam 1 time, and did not attend the physics exam. Let's see what Bob is doing. Bob is 2. Bob is 2 and is taking the programming exam, is taking the math exam, but no physics exam. Right, hence math and programming get a 1-1 and physics gets a 0. Interesting. And finally, let's look at the other two. Alex did not attend any exams. Interesting. Alex is 6 and we don't have any ID 6 in the examinations. Hence, Alex is populating zeros all around. Let's have John. John attended math exam 1 time, physics exam 1 time, programming exam 1 time. Okay, so for John, 13, we have one entry of each, math, programming, and physics. Right, cool. This is a good problem to solve. Let's jump right into it. Let me put the select statement and the various columns to be selected. This is not an intuitive column, attended exam. This is something that we'll have to calculate. We'll move to that. But first of all, as my intuition went, we would want a cross join of the first 2 tables so that we can get something of this sort and then we can populate attended exams. So from, I can take, for a cross join, anything can be left or right. So let me take the first table itself. From students, let me give this an alias of stu because both of them start with an S. Would be confusing. Cross join subjects. Let me call it sub. We don't need to give a on condition to cross join. It will simply cross join. Now we want the solutions for all of these student IDs, subject names, and student names. Hence, if we have something missing in examinations, that should not hamper our solution. So we are not going towards an inner join. We will have to solve it using a left join, with this cross product being on the left hand side, this Cartesian product being on the left hand side. So a left join, right? We need to join it on both of these tables, both of these columns. So left join, first of all, the name of the table, examinations, ex on first condition. Let me join it on student ID. So it is coming from stu.student ID equals x dot student ID, and let me join it on subject name as well. First from sub dot subject name equals x dot subject name. All right, our joining conditions look good. Now what we want to move ahead is to have each of the answers, that is, grouping it by these 3 things. Right, let me take it from here. But first of all, let me give them their correct sources. So student ID is coming from stu, student name is also coming from stu, subject name is coming from sub, and for attended exams, let's solve for this. Actually, this is, and let me just quickly clean this out before solving for that. For attended exams, we want to simply see the number of times a subject is occurring in the examination tables. So in SQL terms, we want to count the number of times a subject name is occurring in the examination tables, that is x dot subject name. So that should give us the number of attended exams, grouping it by these 3 things. So this is what we'll definitely need to pick in a group by clause. Now let me start with group by. First this, picking up this, this. Alright, we have grouped them by these, and hence we'll get the attended exams from the examination table. I think this looks good. Yes, we do want to order them by these two, so an order by will also be needed in this query. We want to order it by student ID and subject name, just the two. Oh, subject name. I think this query looks good. Let's give it a shot. See if I missed something. Alright, the test case is accepted. Let's submit it up. This was quite a good question because I haven't seen a cross-join question yet. Yes, this is the solution to it. We first combined the first two tables and then left joined with the examination table, and we also use the count function. Quite a good question. This is the kind of level that is required in the industry, I must say, in my experience. Alright, moving to the next question. Managers with at least 5 direct reports. Right, we have this table called employee with ID, name, department, and manager ID. ID is the primary key, column with unique values for this table. Each row of this table indicates the name of the employee, their department, and the ID of their manager. Okay, manager's ID is present over here, but that ID can also be present in the ID column, right? If a manager is null, then the employee does not have a manager. Interesting. No employees will be manager of themselves. We only have a single table, and we have been given this information. No one is managing themselves. Hence, these two cannot be same at the same time. Let's look at our problem statement. Write a solution to find managers with at least 5 direct reports. Return the table in any order. Right, what do we mean by at least 5 direct reports? Let's have a look. So I can see this 101 and John without any manager ID. John does not have a manager. Then 102 Dan with some department. I don't think department is required, like important thing in this particular, like to solve this particular question. Department is not being used neither in the answer or in any of the logics. Let's skip it. But Dan has the manager ID of 101, that is John. Alright, then we come to James. James again 103, but his manager is John. Same for Amy, same for Anne, same for Ron. So these 1, 2, 3, 4, 5 people have their manager as John, hence John was given as an output. Interesting. And if it would have gone to 6, then as well we should get John as an answer. So we can consider this single table being a source of 2 tables where we'll be joining them on the basis of ID from the first table, let's say, and manager ID from the second table. And whenever the counts of this will be greater than or equal to 5 of these, like counts of these joins happening greater than or equal to 5, we want to give the distinct name of the manager, the name of the particular manager in that case. That will be coming from a first table. So we'll be using all kinds of things in this question. That's also a good question, but yes, we're using a single table. So let's get on to it. We want the output name as the only thing. Alright, so I'll select name from the name of the table is employee. Let's call this table where I'm only considering IDs as E1, and I want to let's think what kind of a join will be used. So an inner join is looking feasible over here because we don't want to check for everyone, each and everyone. We just want to check the common ones and the ones that are satisfying the condition. So an inner join will be appropriate. Inner join, the same table that is employee. Now this time we want to call it E2 because we'll be joining it on manager ID. The joining condition on E1.id equals E2.manager ID. That's what we want to join and check things on. Now we want to group our solutions. Let me clean this up a bit. We want to group our solutions by name, and I want to pick names from E1, so let me write it as E1.name. A quick thing to fix over here. We want to group it by only employees from the first table. So I'll do a group by from even. I only want to see single things happening, but I don't think John is like name is the correct field to group it by. I think the correct field to group it by is ID because that's what we are joining it on. So to like rephrase it, I don't want John to populate again and again and again because John is also matching with Dan, James, Amy, and Ron. Like this is the condition that will will write it down at the very end, maybe using okay we'll be using having clause over there. But more importantly, we don't want John to repeat again and again, so we want to group them by events ID. I'll get back to it once we complete it. This is interesting, just caught my eye. Having, okay, so by having and not aware, this is something that has actually been asked to me time and time again in interview questions, a very basic SQL understanding question. Wherever we are doing a filtering condition on any column, and we just want to see the values, we are not using any aggregate functions, we use where. But if we're using a aggregate function, and in this case that aggregate function will be a count function, count star, our condition was greater than equal to 5, at least 5 reportees. So since our condition is using an aggregate function, we are using having, otherwise we use where as our condition. So, and whenever this is happening, we want to report the name. And why did I group it by employee ID? Because I don't want John to populate 5 times. That's why I did this. So let me run this query and check for the result. Yep, it's accepted. And just for showing sake, let me, if I comment this out and run this query, I think John will be repeated many times because we don't group it by. It's accepted, right? Interesting. So grouping by was not required. Yep, you see, this can cause trouble. We'll have to keep it. That particular test case survived, but that's not necessary that will always survive. So I'll have to keep this to group it by employee ID. Now if I first run this and then submit it, it should be fine. This is a good catch of this. I think this is the most important part of this question. Other than that, most of the things can be identified if you're good at joins. Yep, as you can see, we must group it by employee ID to avoid duplicates. Alright, we're good to go with this question. Moving to the next one. Confirmation rate. We have a first table called signups with user ID and timestamp. User ID is the column with unique values for this table. Each row contains information about the sign up time for the user with the ID user ID. Alright, this is information about signups for various users in short. Then we have confirmations with the columns user ID. This is the column common. Oh, timestamp is also common, but okay, let's see. And then we have an action of enum type. User ID timestamp is the primary key combination of columns with unique IDs for this table. Alright, we can have multiple timestamps for one user. That is what they want to say. User ID is the foreign key reference key to the signups table. Yep, this is the common column, definitely. Then we have action is an enum category of the type confirmed or timed out. Each row of this table indicates that the user with ID user ID requested a confirmation message at timestamp. That confirmation was either confirmed or expired without confirming timeout. Okay, so this timestamp and this timestamp are not the same. The first timestamp was something regarding when a person signed up for the first time, but if they request for a confirmation, that timestamp is present in confirmation table's timestamp, right? So we won't be joining on this particular table, but yes, user ID is definitely the common one. And then this is also an important condition regarding confirmations or timeouts. But let's look at what do they want us as a solution from this problem. The confirmation rate of a user is the number of confirmed messages divided by the total number of requested confirmation messages. So user will send up multiple confirmation requests whenever it is getting confirmed, and it can get timed out as well. We want to find out that kind of an average of it. So that kind of a quotient to it. So an average will be the solution to find out that particular number, because these are the only two values confirmed and timed out. Whenever it is confirmed, we count it out, otherwise we don't count it out, and we divide it by the total number of confirmation messages. The confirmation rate of a user that did not request any confirmation message is 0. Alright, this condition will help us to solve for the divide by 0 error. So if someone has no confirmation messages, we have to populate their confirmation rate, that's what they want to find out, as 0. Round the confirmation rate to 2 decimal places. We'll be using the rounding function as well. Alright, so to solve for it, then let's first complete the question. Write a solution to find the confirmation rate of each user. So for each user, this help us identify that we'll be using a left join, and we'll be using the sign ups table on the left hand side, so that each user is that has signed up or has given a confirmation or not is getting selected. Right, and we'll have to group it by user ID as well, so that we get unique answers. This is information line. Then we have returned the result in any order, that's fine. All right, okay, so before jumping into writing the code, this is something that I want to share that will help us solve this problem. Is we want to find out the average number of confirmed messages, so we can pick it out by using the if function inside the average function. If the action, whatever the column name is, I think it's action, yes, if the confirmation action is confirmed, then consider it as a 1, otherwise consider it as a 0, and then take an average on the level of user IDs and the number of times the person does this. So once I write the code, I think that will be more clear, but that's the most optimal way that's coming to my mind, the if function of SQL that we haven't used up till now. And we'll also be using the round function. Let's read through the example. These are 4 users, these are their sign up times. Then the confirmations table, there are multiple confirmations per user, as you can see. So let's have a look at the explanations. User 6 did not request any confirmation messages. Alright, we don't have any entry for user 6, and that was a rule, and the confirmation rate has to be populated as 0, rounded off to 2 decimal places. User 3 made 2 requests, both timed out. Okay, user 3, we have these entries, both of them timed out, hence there are no confirmed actions, hence the confirmation rate is 0. 0 divided by 2 makes perfect sense. User 7 made 3 requests, all of them were confirmed, the confirmation rate is 1. Alright, for user 7, 3 of them are made, all of them are confirmed, so 1 plus 1 plus 1 divided by the number of user IDs, that is average happening of confirmed types divided by the total number of times user is present. And for number 2, it is 1 confirmed, 1 timed out, hence it is a 50%. You 2 made 1 which was confirmed, 1 the other timed out, the confirmation is 1 divided by 2. Alright, let's move to writing the code. This is quite an interesting question again. So let me first select the name of the columns, select user ID, confirmation rate. We'll have to calculate this. This is the key of the problem. Let me pick the tables. As I said, we'll be using a left join because we want all the signups to be considered. From signups, we give this an alias of S, left join, confirmations, give it an alias of C. On, we only want to join it on the user ID, as I discussed earlier. We don't require timestamp is simply not common between these two. So S dot user ID equals C dot user ID, that's a joining condition. And we want a solution for each of the signups, so we'll group it by user ID as well. Group by, alright, let me write it as sign up user ID, so S dot user ID, and give it an alias as user ID, grouping it by this. Cool, now let's calculate for confirmation rate. Right, first of all, I think we can start with the rounding function, so I'll give it an alias, start from here. I'll do a rounding function, whatever is inside it, we want to round it up to two decimal places. So that is done for. Now coming to the average function, right? Inside the average function, we want to average it on a particular condition, that is our if condition. So I'll use the if function, open it up. The syntax for the if function is, first we will write down the condition to be checked. So our condition to be checked is the confirmation action should be confirmed. That's when we want to consider it inside the average. So that can be written as c dot action equals confirmed. That's when let me complete the formula. When c dot action is confirmed, then the if should return a 1. That is, we should get a count of a 1. Otherwise, we should not get a count at all. That makes sense. Then we do an average of all these things combined together, rounded off by two decimal places. To clean this formula a bit, let me move it down a bit. I hope this makes it a bit clearer. Okay, just to go about it once again. If the action is confirmed, then we count it as a 1, otherwise we don't count it at all. And we do an average of it on user ID level because we've put it in group by. And then we round it by two decimal places. This looks correct to me. Let's give it a shot and see if it works out. Right, the test case is accepted. Let's submit it. Quite a good question, I must say. And this if approach is like very useful to solve these kind of questions, and in general, whenever we want to aggregate something based on some particular conditions, if is used a lot. So moving to the last question of the day. Not boring movies. This, and by this question we have completed our basic joins. This next question, not boring movies, is from the category of basic aggregate functions, which will be continuing in tomorrow's video as well. Right, let's complete this. And moving ahead, we have the first table called cinema. It has the columns ID, movie description, rating. ID is the primary key, column with unique values for this table. Each row contains information about the name of a movie, its genre, and its rating. So movie name is there, description. I don't see a genre over here, but alright, they have said it. It might be present inside description. Alright. And its rating. Rating is a float. I think this is something that we'll use. Rating is a two decimal places float in the range of 0 to 10. So we have rating at the scale of 0 to 10 up to two decimal places. Write a solution to report the movies with an odd numbered ID. Alright. This is where aggregation functions are being used. We want to filter only the movies where the IDs are odd numbers. So in programming, if you have done this can be done using the modulo function or the percentage symbol on the keyboard, where if we divide or if we modulo any number by 2 and get a remainder of 1, that means it is an odd number of a thing. And a description, that is not boring. So we'll have to see if we are getting both of these conditions satisfied and return all these. Return the result table ordered by rating in descending order. Finally, we'll be using a descending sort in order by tool. Alright, let's move to the example and see an example. We have these IDs 1, 2, 3, 4, 5. Movies are war, science. Alright, these are the movies, these are the descriptions. One of them has boring inside it. Rating, and a question is not boring movies in a descending order of rating. So first things first, we are only considering the IDs 1, 3 and 5 because these are odd numbers. So war, Irish and house card are the only ones to be considered. We have to completely disregard science and ice song. Then we check for these three whether the description is boring or not. So Irish is a boring movie. We are discarding this as well. The only result we want are war because this is odd, and house card. And among them, we are ordering them by a descending order of rating. Hence, house card comes first and war comes second, and we are selecting all the columns. All right, we won't be needing any joins in this question. We can simply extract this information from this single table, cinema only. So first of all, let me select all the columns. Select ID, movie, description, and rating. Right, finally, kind of cool down question from all the joins that we're seeing right now from cinema. Now we want to check our conditions, so I'll put a where clause. I don't see a aggregate function happening. We're simply doing a modulo function to solve for this, so I can use where rather than having. Where I can see my first condition was that the ID should be an odd number, so ID modulo, that is a percentage, 2 is equal to 1. This means the ID is an odd number. And let's move to our other condition, which is and description is not equal to boring. That's the second condition. And we want to order the results by rating in a descending order. Looks good to me. Let's give it a shot. Alright, the test case is accepted. Let's submit it and try it out. Awesome. So we have solved the next set of 5 questions. Thank you so much for watching. If you have any suggestions, please feel to drop down some comments, and I hope this is helping you. This is helping me. I'm able to revise all my concepts of SQL, and I'll see you in the next one. Thank you for watching.